Hey everybody, today we're going to do an example of solving for a variable in an equation. In this case, it's nonlinear and happens to be rational. And so here's the equation we want to solve. We've got f equals g times m1 times m2 over r squared, and I want to solve that for r. And keep in mind, there's often, probably almost always, multiple ways to do things. And so what I'm doing is one particular way to solve this. So if you found another set of steps, as long as everything you did was legal mathematically, there's nothing wrong with going through this in a different route. Okay, I'm going to copy my equation down here where I just have a little more space, and then we'll start working at getting r. So right now, I've got r squared in the denominator. I always like to think how this is going to finish at the end. I want to have r equals something. So I need to get it out of the denominator. I hate that it's there. So the first thing I'm going to do is multiply both sides of this equation by r squared. So over here on the right, we use our cancellation rule to get rid of that r squared in the denominator, and I've got r squared times f on the right side of this equation. Okay, so great, we got it out of the denominator, but now it's attached to this f by multiplication, so I can undo that attachment. I can get rid of that f if I divide. All right, that's my inverse, or multiply by 1 over f. So again, using the cancellation law on the left, we've gotten rid of that f, and over here I've got g m1 m2 over f. And it's perfectly reasonable to also write this in this way, right? The g, just by habit, I tend to put it out front, and so that's the way that I've written it here. Okay, last step, we've got r squared. We need to undo the square. And so I'm going to take the square root of both sides. And one thing that happens, though, when we do that, there are two possibilities. Right? So whenever you have an equation and you take, or when you have something squared equal to something, there are always two possibilities, the positive and the negative result, right? Both of these, oops, I should not have written that square there. Both of these numbers, positive and negative, the square root of this whole mess, will give us r squared when we square them, right? The negative disappears. So mathematically, this is the answer. There are two possible solutions for r. However, and there's no reason you have to know this, but if you've ever seen this equation before, you might recognize it as Newton's law of gravitation, or universal law of gravitation. In any event, r in this case represents a radius, a distance between two objects. And so the positive one is the only one that really makes sense. So if you're in the context of that reality, the only solution that really is valid is the positive one. Mathematically, they're both solutions for r in this case. Okay, thanks everybody. That's it for this one. See you next time.